Hey everyone, so today for math we are going to be completing exercise 4.11, numbers 1 through 5, and together I want to do number 3 as an example, okay? So what this is going to be addressing is something that we talked about in that video call we just had on Thursday, and that is if I have two similar objects or two similar polygons, that the area of the larger polygon is going to be equal to the area of the smaller polygon times k, which is that ratio, that coefficient, twice, either k times k, or what you'll see me do in my answer key is k squared. So for example, if I have the area of a large triangle, and let's say that area is 10, and maybe I know, I'm just making up these numbers right now, by the way. These are not going to work out mathematically, just making it up as an example. And the length of one side is 4, and the height is, actually, what would the height be? 5? Yeah, right? So a height of 5, a side of 4 for this, and the area is 10. Well, my larger triangle, let's say that the ratio, that value k, is 2, because I double 4 in order to get to my large side, which is 8. And if I wanted to know, well, maybe I don't know what the height of this is, and I want to know what's the area of the larger triangle. Well, I know that it would be the area of my smaller triangle times 2 again. So the area of my larger would be 40, okay? And that would fit into this equation like this. The area of my larger equals the area of my smaller times k squared. I know the area of my smaller is 10. I know that k, that constant coefficient, is 2. Squared is going to be the area of my larger. Okay, so that's the process that we want to use. Notice that we want it to look like this, where the that is, we want it to look like this when your k is greater than 1, which is how I've been doing it. Remember in that video call that we just had together, when you're creating your k, I was saying that I always like to put the larger number on top, so that way k is greater than 1. This will work out when k is greater than 1, and only when k is greater than 1, okay? So let's take a second and let's do some of these problems for number 3, because I think that this will do a really good job of illustrating this process, all right? So let me just go ahead, get another layer. Let me minimize this one. Okay, so here for question 3, it says, on the left is a row of 4 triangles, A, B, C, and D. Each is an enlargement of the previous by a scale factor of 1.5. Okay, so I know my scale factor equals 1.5. This is the variable that I've been identifying as k, our scale factor, or which you'll see in different problems, are constant. So here, if I multiply the side for A, the 1.5 times bigger, the side is 1.5 bigger, 1.5 bigger each one. Now for part A, if the area of triangle C is 202.5. Well, that was a terrible color to choose. Whatever, we'll just stick with black. It's 202.5. That's the area for triangle C. Calculate the area of the other three triangles. Okay? Well, remember that equation, we're saying that the area of the larger triangle equals the area of the smaller triangle times k squared. Okay? So if I have the area of triangle C, but I want to know the area of triangle D, I need to set this up. So I'm going to ask myself, which of these two is the larger triangle? Well, triangle D is. So I want to make sure that my larger triangle is on the left, my smaller triangle is on the right with my k squared. Now I can substitute values. I don't have my k over here. Let me add it. It's 1.5. Okay, now I calculate. Not ready, not ready. Okay, so 202.5 times 1.5 squared. The area of triangle D is going to give me 455.625 centimeters squared. So for the first one, that's our answer. Now we want to know for part double I, 2, what is the area of triangle B? Okay, well, I know area of triangle C is 202.5. I don't know the area of triangle B. I still have a K of 1.5. And when I'm setting up this equation again, I want the larger of the triangles, which is triangle C, the area of C. Times K squared. And now simplify. So 1.5 squared, I believe, is 2.25. In order to isolate the area for triangle B, I want to divide both sides by 2.25. This cancels out, leaving me just the area for triangle B on the right. And when I divide 202.5, divided by 2.25, it gives me an area of 90 for triangle B. Now that I've found triangle B, I can find triangle A. So again, I have triangle B, which is 90. I don't know triangle A, but I do know that my constant is still 1.5. I'm sorry, my scale factor is 1.5. Okay, from here, I can set up my equation. I know that my longer triangle is going to equal, or I'm sorry, the area for the larger triangle, the area for the larger triangle is going to equal the area of the smaller triangle times k squared. Substitute my values. I don't know the area of triangle A. And isolate. And so the area of triangle A is 40 centimeters squared. Okay, and so now we've done parts 1, 2, and 3 for A. Now when I look at part B, it says if the triangles were to continue in this sequence, which letter triangle would be the first to have an area greater than 15,000 centimeters? So one way that I can do this is I can solve for, I already have a triangle D. I could then find the area for triangle E, and then find the area for triangle F, G, H, so on and so on, until I get to a number bigger than 15,000. But what this question wants us to do is it actually wants us to set up a sequence. We have not learned, so for 3B, we have not learned about sequences yet. We have not learned about sequences yet. No, that was ridiculous. Okay. So we cannot solve this problem efficiently. Okay? So therefore, don't do it. Okay, so please email me if you have any questions. I will release your step-by-step answer key Friday evening, so please try and do these problems first. I will give you an answer key for the other questions, okay? Other than that, have a great day. See you guys next time.